Let's try example 2. It wants us to differentiate f of x is equal to the square root of x times 2 minus 3x. So once again, I'm going to go ahead and call this factor 1. I'm going to call this factor 2, which means that in this case, I'm going to say that d1 is going to give me 1/2 x to the negative 1 over 2, remembering that the square root of x is literally just the same as x to the 1/2. And d2 is going to give me negative 3. So now I'm going to use that and say that f prime of x is going to equal factor 1 square root of x times d2, which is negative 3, plus factor 2, 2 minus 3x, times d1, which is 1 over 2, x to the negative 1 over 2. Now, if you wanted to, you could have said that factor 1 here is also x to the 1/2, because we know that that's what it represents. That's perfectly fine as well. Because when we get to the next step, we're going to say that we have negative 3 x to the 1/2 plus 1 x to the negative 1/2 minus 3 over 2 x to the 1/2. And now I'm going to factor this. So remember, I'm going to factor out the smallest exponent for x, and I'm going to factor out this denominator. So I'm going to say that I'm going to pull out a negative 1/2, and I'm going to pull out the smallest exponent for x, x to the negative 1/2. And that's going to leave me with 6x minus 2 plus 3x, which is the same as negative 1 over 2x to the negative 1/2 times 9x minus 2, which I can rewrite as negative 9x minus 2 over 2 and the square root of x. Now, if you want to cancel out that negative, you can apply the negative into here and then just say that it's going to be the same as 2 minus 9x over 2 and the square root of x. That is also true. All right, let's take a look at example 3. If y is equal to x to the negative 2 times 4x cubed plus 2x minus 5, then what is the derivative of this going to be? So we're going to write using proper Leibniz notation for the product rule, and then we are going to simplify. So what do we know about this? We know that we're going to have dy over dx is going to equal the first factor, x to the negative 2, times d over dx of the second factor, 4x cubed plus 2x minus 5. And I combine that with the second factor, 4x cubed plus 2x minus 5 times the derivative of the first factor, x to the negative 2. We can still see that here we have factor 1, we have derivative 2, we have factor 2, and we have derivative 1. Then we're going to take the derivatives. So I have x to the negative 2, and the derivative is going to give me 12x squared plus 2 plus 4x cubed plus 2x minus 5, and when we take the derivative, we get negative 2x to the negative 3. And at this point, we're literally just going to multiply them out. So we're going to expand this into here. We're going to expand this into all three terms in here. So that is going to give us 12 plus 2x to the negative 2 minus 8 minus 4x to the negative 2 plus 10x to the negative 3. This is going to be when I combine my like terms. I have 2x to the negative 2. I have negative 4x to the negative 2. So I can combine those. I have my two constants. I have the 12 and negative 8. And then I have my 10x to the negative 3, which does not have a like term, which means that I have 4 minus 2x to the negative 2 plus 10x to the negative 3. Now I'm going to pull out the common factor, the lowest exponent for x, which is x to the negative 3. And when I remove that, I'm going to take out a common factor of 2. I'm going to take out the x to the negative 3. And when I divide what is actually 4x to the 0 by x to the negative 3, I'm going to get 2x cubed minus x plus 5. Or, when I move that x to the negative 3 to the denominator, 2 and 2x cubed minus x plus 5, all divided by x to the power of 3. All right, for example 4, it says it wants us to calculate the slope of the tangent to the graph of the function f of x is equal to 3x squared plus 2 times 2x cubed minus 1 at the point of 1 and 5. Remembering that this is the derivative and it told us the point it's at when x is equal to 1, as we can see from our coordinate over here. We can also see that we have factor 1, we have factor 2, which means that I can solve from that. The derivative of 1 is going to be 6x, and the derivative of 2 is conveniently enough going to be 6x squared. So, first thing we're going to do is we're going to state that f prime of x is equal to factor 1, 3x squared plus 2 times d2, which is 6x squared, combined with factor 2, 2x cubed minus 1 times d1, which is 6x. Now, both of these have a common factor of 6x. So I'm going to pull out 6x, and I'm going to be left with 3x squared plus 2 just times x, and I'm combining that with just the 2x cubed minus 1. Or 6x and 3x cubed plus 2x plus 2x cubed minus 1, which is going to give me 6x and 5x cubed plus 2x minus 1. Now, what do I know? I know that I can substitute in my value. This is when x is equal to 1. I have my derivative. So I'm going to say that I have 6 times 1 multiplied by 5 times 1 cubed plus 2 times 1 minus 1, which is just the same as 6 times 6, which is going to give me a slope of 36. Now, it's important to note that even though we did the process, which is a good habit to get into, could we have just substituted in x is equal to 1 into our very first statement? Yes. This was not actually necessary. But it's good practice. It's always nice to be able to simplify. All right. One last example. So it says, let y equal u times v be the product of the functions u and v. Find y prime at 2 if u2 is equal to 3, u prime at 2 is equal to negative 4, v at 2 is equal to 1, and v prime at 2 is equal to 2. So what do we know? We know that y is equal to u times v. We're going to call that factor 1, factor 2. We know that y prime is equal to u times v prime plus v times u prime. We know that we're trying to find y prime at 2 when we have u2 times v prime at 2 plus v at 2 times u prime at 2. And we know that u at 2 is going to give me 3. V prime at 2 is going to give me 2. V at 2 is going to give me 1. And u prime at 2 is going to give me negative 4. This means that I'm just going to be left with 6 minus 4, and y prime at 2 is literally going to give me 2. Using the same principles and knowing what the values of u at 2, u prime at 2, v at 2, and v prime at 2 are, we can solve what y prime at 2 is going to be.